What's up, Open Specky fans? Excited to show off the new website. We've been doing a ton of development to make this website easier, more visually appealing, have some more features. Hope that you'll like them. Keep the input coming. Please continue to suggest updates and new features for us to add to the tool. So I'll start out here just on the home page. We've added some better graphics here so that you can really quickly get to the information that you need about the tool, know how to highlight feature requests, get some data, stay up to date, all the terms and conditions, everything like that. I guess the main new thing is this video tutorial. Just gives a brief overview for new folks how to quickly find information within the tool. Oh, am I not screen sharing right now? Let's see. Oh yeah, I think I am screen sharing, but it doesn't look like it. Anyways. So let's get started. The interface is really similar to the previous one, but we've reorganized some of the buttons. You can go here to the upload file tab to get started. If you don't have any data and you're just new to the tool, you can download this sample file. All it is just a CSV file that has data in it of a Raman spectrum for HDPE. And you can see here what the CSV file format is that OpenSpecky is expecting. So if you format your CSV files with wave number and intensities as the column headers, it'll know what the data is underneath those columns. So you can see here, this is just the spectral information. You can also upload SPC, SPA, .0, JDX, ASP. We're advancing a few other tools as well. So we will continue to add some more features there. All right, so you can download data. If you would like to share your data, you can have this selected before you download that data. So right now it's enabled, so I just shared data to the OpenSpecky database. This is also going to be tracking all of my clicks, so that way I have a full record of all of the information all of the procedures that I conducted on my spectrum while I'm doing it. So it really provides a really great utility for the spectroscopy community at large, as well as for reproducing your own research later on. So I would definitely recommend having that enabled, but if you don't want to share your data, then make sure that it is selected like this so that your data will not be shared. All right, so like I said, I like to share the data. And what we'll do is, so this is an absorbance spectrum. You can also upload transmittance or reflectance. And if you do, then you'll want to use one of these intensity adjustments. Before moving on to the next page, I'll just briefly mention that you can also upload metadata here. So if you want to add some information about the spectrum, like whose spectra it was, if you know what type of material the spectrum is for, then you can input that information to here. And then down here, you can click share metadata after you input all of the metadata information that you'd like about that data. And what that does is it just really helps us to make this tool even better by having more information about the spectra that's being added to it. Our goal is to make spectroscopy as accurate as possible. And we think by having data shared like this, we're going to be able to make that a reality. So thank you to all the people who have been sharing data, and please continue. All right, and then so moving on, you want to pre-process your spectra. So it's always good to clean up your spectra before you start. Basically, for those who are unfamiliar with spectral processing, We have the original spectrum here in yellow, and you can see it's got a little bit of noise through here. Those aren't real peaks. These are some peaks here. And the goal is to essentially first smooth out as much of that noise as possible while retaining the peak shapes and relative heights. And then also to remove what's called the baseline. So essentially this signal here is elevated from 0, but we want only peaks to be elevated above 0. So to do the smoothing first, we can click this button here and we can manipulate how smooth this is. And so actually the default setting on OpenSpecy, I don't know if you noticed, but it was kind of removing a little bit of that peak there. I can zoom in here and show you. It was removing a little bit of this peak, and I don't want it to do that because I want to actually be able to see that peak. So I'm just going to increase this polynomial, which makes it less smooth, by 1. And that will decrease the amount of smooth that was there. Also over here, I'm seeing this, this little bump, which isn't actually a peak. And right in here, I'm seeing this bump that's not a peak. And so I want to decrease those. And how I do that is I do baseline correction. So we can click this here and we just change this baseline correction. You can increase it and decrease it. Sometimes it works a little better to have a higher order polynomial than a lower order. Basically what it's doing is it's iteratively fitting to that baseline. So it's fitting a polynomial regression to the entire spectrum. And then it figures out where the peaks are and removes that from the data and then continues to fit and fit and fit until it finds just the baseline. And usually, I mean, you saw even the default setting was like good enough, but it's better to have it even cleaner, to have it be really everything besides the peaks are as flat as possible, close to 0 as possible. So this spectrum is pretty good, pretty cleaned up. I would say it's ready to go. If you wanted to change the range, so some people might want to like crop off these non-peak regions outside of the data or just focus in on a peak, you can also do that here. I'm not going to focus on that right now. If for some reason you wanted to not smooth your data, like let's say that it's already smooth, you're uploading already smooth data, you can just remove the smoothing here and you can see how that made it a little bit more noisy. And same thing with baseline correction, you can just remove the baseline correction. Okay, I always recommend that folks download their data here. What this is this is a fully cleaned up version of their data using the parameters. So you can see here, we uploaded this data and now we have this new cleaned up version. This is the pink data set here, the processed data set. And so that'll help for your records just to know what the spectrum was that you fully processed. And also if you want to take it into another software or something like that to do identification, you can totally take this spectrum and do that there. Some other cool features on this interface here, you can download this plot as a PNG. So you can click here and see the PNG file. I already showed zoom in and zoom out, but also it has these peak identifiers. So if you zoom over, you can see the exact peak locations. For this one, the peak is at 1,294 wave numbers. And that will help for if you're trying to reference individual peaks and trying to understand what sort of chemical bonds are associated with those. You can look them up from different reference guides. All right, and then going over to the match spectrum. So what this has done is it starts out, the default settings here are in Raman spectrum. So if you have an FTIR spectrum, you'll want to change that to FTIR, but this is Raman. So we'll just leave it as the default. The spectrum to analyze, so we have processed or uploaded. Processed is the pink spectrum from the previous tab, and uploaded is the yellow spectrum. So it's just like the raw uploaded spectrum or the spectrum that you processed in OpenSpecy. And then region to match is telling OpenSpecy if you want the full spectrum to be matched or if you want just the peak regions to be matched. So OpenSpecy has two libraries. One library has the full spectrum in it. So every reference material in the libraries has the full entire signature. And then the other library has removed all of the non-peak regions. And that can help in some cases to find the correct identification. There have been some recent papers that have suggested that that improves accuracy by quite a bit. So I'm just going to leave this. These are the default settings. We calibrate all of OpenSpecky's procedures to default settings that are going to be above 90% accuracy. And how we do that is we take OpenSpecky's library and we take each reference spectrum out of the library, augment it to kind of distort it a little bit using basic principles of spectroscopy. And then we try to match it back to the library using our default settings. And so you can rest assured that if you upload something that looks very similar to one of the spectra in the library, but not exactly, then you'll get a good match with the default settings, as long as you change this one here for your spectrum type from Raman or FTIR. All right, so yeah, so this is the match. This is the top match that I get here returned. So it's saying HDPE, which is great because that's the match that we're expecting. HDPE from Jennifer Lynch. There's some metadata here about that. It's a Raman spectrum, sample ID. We can also, if we want to get some more certainty about this, we can kind of play around with the different settings, check if the peaks only library matches to the same thing, for example, and it does. We also get HDPE from the Jennifer Lynch library. So that's reassuring that that is probably a really good match. And you can select different spectra here. So let's just find something different besides HDPE or, okay, there. So we can select this spectra and kind of see if that's a better fit to the data. You can also select different organizations, so different databases within the group. So these are the group names from the reference library. So you could have the Cavernard et al. That's from a paper. You could add the Hariba Scientific Library. You could add in the Raman Open Database. And you could just look at those specifically, for example. And those are also telling us, yeah, HDPE is probably the best for those choices too. So that's another way that you could get some reassurance on your spectral match. If you are speaking another language other than English, we haven't fully made OpenSpecy compatible with all languages, but we have added in this Google Translate feature, which will allow, for example, to translate the entire website into Bulgarian. I'm not positive that all of these translations will make perfect sense, but if you would like to contribute by helping to translate OpenSpecky into other languages, please do. If you have suggestions on how certain languages could be represented better from this Google Translate, please reach out and let us know. We'd love to make this more accessible to people around the world. All right, and then lastly, this is all volunteer based. So if you have the funds to donate, please donate. You can donate via PayPal, or you can visit our swag shop. We have some OpenSpecky merch, so you can show off your true colors. And we'll be adding some more merchandise options to that too in the future. Yeah. Thanks again for being a part of the OpenSpecky community.